Good morning. It is Tuesday, the 11th of October, and we're going to start on something new today. Now, I sent out an email this morning that, as it said, I made the decision. I was going to go into chapter 17 next, but I decided, you know what, I'm just going to follow the lead in the book. So what we're going to spend the rest of this week on is chapter 12. You probably won't have any homework this week, but we'll see. Like I said, so as it says there, today we will begin our discussion of object-oriented programming. All right, I am going to lecture on chapter 12, probably starting in about 5 minutes. All right, and as it says, we will spend the next 2 to 3 weeks on section 3, which is object-oriented programming. Now, before I start on that, I just wanted to show you something else here, and let me show you that right now. I'm not going to go over what I'm showing you here, not a bit. We're not going to spend a second on this, other than to just mention to you, this is kind of where we are right now. In other words, you should be able to build an interface that looks like this. We've been introduced to things like labels and text boxes and buttons. And in the last couple chapters, you've learned about combo boxes, etc. You know how to create a form, you know how to rename a form, you know how to set cancel buttons and accept buttons, you know how to set tab order, etc. And basically, you could make this interface. All right. And not only that, when you start to look at it, the stuff that's here, the stuff I've got highlighted right now, what we learned in one of the last chapters was how we could even take that information and store that on a separate form and then go back and forth between forms. All right, so that's just very quickly, that's a review of what we have done so far. But what we're going to be moving toward for the rest of the book is the fact that right now, and we're not going to exactly talk about what I'm going to mention right this second, but we're going to get to it. And that is, we can run this program. We can enter in 10 employees. We can get information from all 10 employees. We can keep up statistics for all 10 employees, etc. But as soon as we click that exit button and stop running the program, that information goes away. In other words, the information is not persisting. So when we get to the last part of the class, probably starting in around a month or so from now, somewhere around there, all right, then we're going to be talking about databases, and that'll take up the rest of the book. All right, but before we get to that point, okay, and one more time, let me change my share here. That's not what I wanted. Let's see. There we go. Let's talk about, so again, I'm not going to say a word other than we've done all of section 1. We've done all of section 2. All right. And I very quickly built a simple form. There's no code. I didn't put a lick of code in that form. I literally built it 5 minutes ago. All right. But all the stuff that's in there, you know how to do. All right. So we went through, there was not a whole lot in section 1, but in section 2, you should now be comfortable working with numeric data and working with string data. You should now be comfortable with working with control structures. You should understand if statements. You should understand switch statements. You should understand for loops. You should understand while loops, even do while loops. Okay. Now, a couple things that are in here that are going to kind of bleed into what we are going to start talking about in chapter 12. In chapter, I think it was chapter 3 in the book, so it was a long time ago. You can see the chapter was entitled, or is entitled, How to Code and Test a Windows Forms Application. In there, they began to talk about object-oriented programming. And they mentioned, for example, that every time you create a button, it's a button object because buttons are part of the button class. Every time you create a form, it's a form object because forms are part of the form class, etc. All right. And then when we got into chapter 6, was entitled or is entitled How to Code Methods and Event Handlers. Well, one thing about this is with what we've been working on right now, typically, if I go back, I'm not going to, but if I go back to the program I showed you at the beginning of the class and I double click on the, let's say the calculate button, it brings up the calculates click event. Okay, and you know that, that's no big thing, but that's an event handler. So in other words, when that button is clicked, we can put code in there that we want to have run. Similarly, we can do things in the clear button. We can do things in the exit button. All right. You've also found out that when you've got a drop-down list, we can put code in so that when the selected index changes, so when you go from one option in a drop-down list to another, different things can happen. All right. So we've talked about a lot of this stuff already, and we're going to continue talking about it. And we got to chapter 7, and by now, hopefully, you've got somewhat of a comfort level talking about exception handling, using tries, using catch, being able to throw your own exception, validating data. That was in the infamous page 213 in the book, where we had the built-in Murach validation methods, the is present, the is within range, and the is in 32 or is decimal. All right. And we talked about how to use the tag property with that. So again, I'm just reviewing. Okay. Then we got into chapter 8 and we got into arrays and collections. Now we did a lot of work with arrays. We did very little work with collections, things like lists, etc. We're going to do more work with those in section 3, just so you're aware of that. And then we finished up the chapter and what you just had your test on yesterday. We talked about dates and strings. We talked about how to add some of those additional controls. Again, things like list boxes, check buttons, radio buttons, combo boxes, drop-down lists, etc. And then we went over some more debugging in depth and more depth and breadth of coverage. So that's the first half of the book. All right. And we're 370 pages in. All right. So what do we have to go? Well, let's just, for now, let's forget about section 4 and about section 5, and let's just look at section 3. What we're about to go into is how to create and use classes. All right. This whole section, as you can see by the title, is on object-oriented programming. We're going to talk about all that. The way I'm planning on attacking this is today we're going to go over all of chapter 12, every single bit of the stuff that's in chapter 12. I'm going to look at the code that Murach has put in the book. I'm not going to bring it up in Visual Studio Code. We're just going to look at it inside of the book itself. This is one of the longest, if not the longest chapter in the book. It's about 55 pages long. All right. So we're going to talk about that today. Tomorrow, we'll actually bring the code up, and then we'll go and we'll write a little bit of our own code to go in and create our own class. And we'll talk a little bit more about some of the terminology that's in here. All right. That's going to take up. All right. If we get all that done by tomorrow, that's great. Then on Thursday, I'm going to go through a couple of the problems that you will still be assigned, but we'll do a couple of them as we have been doing in class. All right. And Friday then will be lab for the entire period. Okay. We'll see how it goes, when we get to that point. Next week, sometime, I don't know when, but I will lecture on chapter 13. That said, you will be responsible for chapter 13 only for doing the written test. There'll be no homework. There'll be no labs from chapter 13. Then we'll go into chapter 14. All right. And when we go into chapter 14, all right, we'll kind of do it the way we're doing it today, in that we will take a look at a class and a program that we've already created, and then we'll add inheritance to it. Okay. And then finally, probably in a couple weeks from now, we'll go through chapters 15 and 16. All right. And that'll get us, you can probably look at, this is my take on this right now. There will probably be a test just on chapter 12. And then there will be another test that will combine information from 14, 15, and 16. For 16, we're only going to talk about maybe 10 of the pages in the chapter, but we'll talk about what's due and all that other stuff as we get going in here. All right, so you don't have to worry about it. All right, so we're going to jump into chapter 12. But before we do, I just want to give you very quickly a non-computer example of the kind of things that we're going to be talking about. All right. So I live in Lake St. Louis, Missouri, and my daughter lives in St. Charles, Missouri. The reason I'm telling you that is that quite often my wife and I go over and we babysit my granddaughter. And when we do, oftentimes we go by and we take Highway 364 east. All right. And we get on there and we go out to her house. The reason I'm telling you that is if you've ever driven on 364, maybe you've noticed that it seems like almost every time there's a tract of land of any size, some developer buys it up and starts creating houses on it. All right. That's just the way that it is. But what this has to do with anything is imagine, just imagine for a second that what has happened is a developer has bought a plot of land, and I'm just making all this up literally off the top of my head right now. So a developer has bought a plot of land with 250 acres on it. All right. And what the developer plans on doing on that 250 acres of land is to go and create 100 different houses. Each house, each house will be on an acre, let's say an acre and a half of land. So that's 150 of the acres. Then there'll be things like there'll be a playground in there and there'll be streets in there, et cetera, et cetera. Well, so what does this have to do with anything? All right. Imagine again that the developer is going to develop 100 different houses. Over those 100 different houses, the developer goes and brings in an architect who literally sets up 10 different house plans. All right. And so there'll be house with plan one, then two, then three, then four, then five, then six, then seven, then eight, then nine, then 10. Then in the next row, so to speak, they'll do it again. Well, the reason I'm telling you that is each one of those house plans that gets created by the architect, each plan would be the equivalent of a house class. It would have things in it like, for example, how many windows are going to be in the house, how many stories are going to be in the house. Not, not so much things like color, etc., but things that every single house that you build like that would have. Imagine that they'll all have 3-car garages, etc. So when you are starting to set up a blueprint, which is basically what architects do, when you start to set up a blueprint for the houses, all right, those become your house classes. Now, you go and you build 10 of a certain blueprint. Each house could have a different color. Some houses could be sided. Some houses may have shutters and some may not, etc. So what I'm getting to is the blueprint is the class. Every instance of one of those classes is called an object. And really, when you think about it, if I had to sit there and take the concept of object-oriented programming, I want to put it into a nutshell. In other words, I want to explain object-oriented programming to you in one sentence. Now, that said, so I'm taking what's in over 200, maybe 180 to 200 pages in our book, and I'm boiling it down to one sentence. So it doesn't ring true 100% of the time, but basically what object-oriented programming is about is the use of public methods to manipulate private data. The use of public methods to manipulate private data. Now, even public and private, we've talked a little bit about that, but not in a lot of depth and breadth of coverage. But I said public methods, all right? Do all methods have to be public, or can we make private ones? Of course we can make private ones. But most of your methods are going to be public. As far as data goes, I said private data. Can there be public data? The answer is yes. It's not highly recommended, but yes, you can do it. So I'm giving it to you, like I said, I'm giving you a boiled down one sentence version, but there's always going to be exceptions to basically every rule that you can go over. So with that said, let's get into this. So before we even do this, we are now in section 3. I'm not going to read this to you, but basically it just says chapter 12 is going to talk all about classes. Chapter 13 is going to give you some advanced features of classes. Chapter 14 is on inheritance. Chapter 15 is on interfaces. And chapter 16 kind of ties it all together and talks about how you can nicely organize your classes. So that's what we have to look forward to, pretty much, I would guess, at least, for the rest of October. All right. Now, I went back yesterday. No, believe it or not, I've probably read the chapters in this book a good dozen times. All right, over the years. We've used this book probably now for about 3 years. It's fairly timeless in that a few things have changed with newer versions of C#, but the material in here is still very, very, very relevant. All right. So it says there on here, we're going to learn to create classes that include properties, methods, fields, and constructors. Also classes that contain static members. And that's what most of this chapter is about. All right. We are going to look at today and tomorrow, some of the built-in stuff. Built-in is wrong. We are going to look at some stuff that's already been created for us. All right. Starting tomorrow, we're going to go in and we're going to build our own thing. All right. And no, this isn't the thing that we build tomorrow. No, you won't have to build it with me. No, you don't have to key it in. No, it won't be due, etc. I'm just trying to go through the stuff that's in here because this, in my opinion, this is the hardest section in the book. The stuff we do next with files is not difficult. Then we go into link. It's quirky because of the syntax, but it's not difficult. We go into databases. They're still difficult, but I don't think they're as difficult as classes. And our databases are going to use the stuff that we talk about in here. All right. So this is broken down into what, about 5 or 6 sections. So the first 10 or so pages in intro to classes. Then the basic skills for creating classes. All right. That'll take us at least to our break, if not further. Then we're going to look at this product maintenance application. All right. This is the one that's built into the book, or comes with the book, I should say, and we'll look at the actual code in Visual Studio Code tomorrow. Today, we're just going to look at the code, period. Then we'll talk about some more skills you'll need for building classes, go through how you can use Visual Studio to kind of maneuver your way around classes. And the chapter ends with talking about structures and records for the last 10 or so pages, maybe not even 10 pages, 7 or 8. Now, I'm not going to give you any work. You will have no homework. You will have no labs. You will have no tests in this chapter that will discuss structures and records. I believe that the concepts of structures and records will be on the written test for chapter 12. So the reason I'm telling you that is we'll go through that section fairly quickly. All right, so buckle up, as they say, because we're going to get going right now. All right, now I'm going to mention a term right now that is not mentioned in your book. To my knowledge, I don't think it's even in this book. All right. What they're going to talk about very quickly in this section is something that's referred to as a multi-layered architecture or a multi-tiered architecture. All right. And I'm going to give it to you in another way. What we're going to start talking about in here now, right now, is what I consider to be what's referred to as an M like Mary, V like Victory, C like Charles, an MVC way of doing things. And MVC is an acronym that stands for Model, View, Controller. All right. And really, you know what some of this is already. What do I mean? Well, view is basically when you run a program, it's what the user sees. So again, going back to the big form I showed you at the beginning of class today, once you run that, the view is just basically that form. If we had two forms, the view would be both forms. All right. The model, really the model part of it, we're going to pretty much put off until we get into chapter 19. That's the database stuff. And the controller is the logic that sits between the view and the model. All right. And I don't expect you to remember this. You don't have to. But think about it this way, if it confuses you. Let's say that, believe it or not, today is my wedding anniversary. All right. And let's suppose I'm taking my wife out to dinner tonight, and we go to a really nice restaurant. We walk in there, and the waiter comes up to us and says, he gives us the specials, et cetera, et cetera, et cetera. But what the waiter does is eventually she or he comes back and says, "Are you ready to order?" Okay. Well, what do? We order. Okay. And what happens? Typically, the waiter or waitress might walk into the back room and give that order to a chef, etc. But what doesn't happen is the waiter or waitress doesn't sit back there until our meal comes and then takes it out to us. Or after we order, the waiter or waitress doesn't give the order to the chef and then come back and stand by us. All right. So why am I telling you this? Okay. Because that's sort of a model view controller operation. All right. And you can look at it as the controller in that case is the waiter or the waitress. The waiter or the waitress is able to go and work with multiple people at the same time. All right. And we're the view. And other people that the waiter or waitress is servicing, they're the views. And the chef is kind of all right, it's kind of the model in this case, maybe not the greatest of examples. All right. But when we take a look in here, this is what they're saying. When you get this three-layered architecture, which is what they're showing in here, we've been concentrating almost exclusively on the presentation layer. You've learned how to create console applications. You've learned how to create GUI applications. You've learned how when you've got a GUI application that you can go from one form to the other. But we've really done very little to nothing with the middle layer. We've done nothing with the database layer. This particular section of the book is on this middle layer, talking about the business classes. When we get to chapters 18 to 22 or 19 to 22 or whatever it is, we'll be talking about the database layer. All right. So they talked about this and they mentioned that it's a three-layered architecture where the presentation layer is what the user sees. The database layer handles basically all of the data. And again, as I mentioned at the beginning of class, we're going to want that to persist. All right. Then in the middle layer, that's where we're going to write, basically, for lack of better words, our business rules. And if you say business rules, I don't know what those, yeah, you know what those are. All right. I mean, if you sign up for classes at Rankin Technical College and you want to go and get a degree, you've got to pay, right? That's the way it works. If you sign up for this class, you either have to attend in person or you have to watch the videos. If you sign up for this class in St. Louis, you've got to attend in person. And if you miss more than 6 times, you're dropped from the class unless you've got some kind of a valid reason. Those are all business rules. All right. So it says oftentimes the classes that make up the database in the middle later, they're put in class libraries. In other words, what they're saying here is, why do we even care about this stuff? Because if you are working in a big company, you can take the responsibility, the stuff that has to happen, and you can break it down, and you can have more than one person working on it. So as it says, one advantage of developing applications in this way is it allows the development to be spread among members of a development team or of several development teams. So you could have a database department, and you could have a user interface department, and you could have a business objects department, etc. All right. And once you create that kind of stuff, if you know what you're doing, and this is what we'll talk about in chapter 16, you can put this stuff in libraries so you can reuse it. And even with that, sometimes students get confused as to what I mean by that. So let's give you a quick example. Let's suppose that I don't know, that I'm at a meeting that has people from business and industry in it, and we all go around the table and talk about what we do, etc. And I mentioned I'm an information technology instructor at Rankin Technical College. And then we have a talk for a while, and then we have a break. And during the break, somebody comes up to me and says, "Hey, um, I work for this hotel chain, and we're brand new, and we want to set up a system for our reservations, and we have absolutely no idea what to do or how to do it, etc. Could you write an application, all right, that would set this up for us?" And let's just say yes I can, and let's say yes I do. All right. Now imagine that I've done that, they're very happy with it, and one of the things that happens at this hotel, because they get a lot of out of town visitors, is they also rent cars from right at the hotel itself. All right. And now the people who own the car rental place come to me and say, you wrote this reservation system for the hotel. Our reservation system isn't that much different than that. So if I have written this and set my stuff up into class libraries, all right, hopefully then I can grab, just like you grab books out of a library, I can grab pieces out of that library, and I've already got the framework to start working on a reservation system for automobiles. All right. And then finally, as they mention here, it says the last advantage is you can run the different parts of the application on different computers, and that can improve performance. Well, one of the things we've already seen, I think we've talked about already, all right, is a little bit about client server, maybe not much, but the idea is if I go out to Amazon, I'm not going to do that right now, but if I go out to Amazon and let's just say I'm looking for a book on C# classes. So I go to books on Amazon and I put in C# classes and I hit enter. And the system comes up and it shows me all the books that they have there on C# classes. Well, probably the machine that held that information that just showed me all the different books on C# classes, probably at least, that's not the same computer, not the same server as the one that came up when I first went out to Amazon. All right. They spread the work around. You can't have one machine that does everything. So for instance, if I had asked for videos, I might go to one server or one group of servers in one place. If I asked for sports equipment, I might go to a server or servers in another place, etc. So what you can do when you put this stuff into different layers is you can basically set yourself up an architecture that can run on multiple machines, all right, which will typically make it run faster. All right, that was a very long introduction. Sorry about that, but let's talk a little bit about some of the terminology that's going to be in here. All right, so it says the members of a class include its properties, its methods, and its events. We're going to talk about each one of those in turn, starting in just a couple minutes. There's also a special kind of method that's called a constructor that we'll talk about. All right. Built-in classes in .NET all have properties, methods, and events. Classes that you design yourself also typically have properties, methods, and events. You go, well, what about constructors? A constructor is just a special kind of method. And we're going to talk about all of that in just a bit. All right. Now, there's going to be some tables that we're going to look at in here, and we'll look at them in just a minute. But before we do, there's a term here. If you look up on your screen right now, it's at the end of the first paragraph that's showing that's called encapsulation. When something is encapsulated, it's hidden. What do I mean by that? I'm not going to bring it up right now. I might have done this for you before. I might not have. It's no big thing. But if you can imagine that right now, I brought up the calculator on this computer and I put in a number, 1089. All right, just number off the top of my head. So 1089. And I typed it into the calculator and I want to know the square root of that number. So it's got a square root key on that calculator. So I hit it. It says it's 30 something, 36 something, let's say. I don't know what it is. I don't care. All right. The logic that makes this work from the time I put in the number and hit the square root key until I'm shown an answer, all right, that logic is encapsulated or hidden from me. All I see from here is what's referred to, all right, is the interface. So the interface, when I turn the calculator on, it's just an empty calculator. Once I put in 1089, now I've started to put things into my interface. Once I go and click the square root button, I'm still working with the interface, and then it gives me an answer. Let's say it's 36.13. All right, that's all part of the interface. The implementation is hidden from me. All right, I have no reason to know how the system determines the square root of the number. Not only that, if for some reason, let's just pretend for a second that some math whiz figures out a better way of doing square roots than the way we've been doing it forever. And it's faster, it's more complete, etc. Well, if the people who create the calculators can go in and just reprogram the calculators so that it uses this new thing, but so they've recalculated, for lack of better words, the implementation. But if the interface still looks the same, I'm none the wiser. So again, encapsulation basically is the idea of hiding things, inside of an implementation and only showing the user the interface. Okay. Now, why is this even important? When I decided to move to Missouri about 6.5 years ago, I wanted a job. I wanted to stay into education. I was lucky in that one of the jobs I almost got was for, what is it, ITT, the college that closed. All right. But I did have a phone interview with St. Charles Community College. And it lasted well over an hour. Either they weren't impressed or they had a better candidate because I wasn't offered the job. But one of the things they asked me was, can you give me a detailed description of the subject of encapsulation? Encapsulation is one of the hallmarks of object-oriented programming. It's one of those things that you have to understand. All right. And we've been, whether you think about it or not, you've been using encapsulation all semester. I don't know about you, but if I've got a text box that's called TXT first name, and in my clear routine, I say TXT dot first name dot text equals double quote, I have no idea in the background how that stuff is actually cleared out, and I don't care. All right, all I see is the interface. I don't need to care about the implementation. As a programmer, if you write your own classes, you create both the interface and the implementation. All right. So this is one of the things that we're going to be working with more tomorrow, but we're going to start looking at it today. We're going to work with actually 2 or 3 different classes, but the first one we're going to look at is what's known as a product class. So the name of the class is product. It has 3 properties. It has a code property, a description property, and a price property. It has one method that's called getDisplayText. Sometimes when I start to give this kind of lecture, their eyes start to gloss over and they get confused. So think about it just for a second again. Let's forget about computers. And let's imagine that instead of having a product class, let's imagine we were making a person class. Then a person's properties could be height, weight, eye color, hair color, gender, etc. Those would be their properties. Everybody has those properties, but they're unique to every person. All right, then under methods, you could have eat, sleep, drink, etc. All right, and we all eat, we all drink, we all sleep, but we all eat different things. We all sleep a different amount of time. We all drink different things. All right. When you look at this, and we've talked about this kind of thing before, what differentiates a property from a method is the method must have parentheses, which may or may not have some kind of parameters in them. All right, then we've got constructors. A constructor is a special type of method. It's a special type of method that gets called whenever you create an object of the class. So in other words, every time I create a product object based off the product class, it's going to call one of those 2 constructors that are right there. And the first one just has 2 parens, and you go, well, that doesn't do anything. Yes, it does. It takes any number that we've set up in here, like price, and it sets it to 0. It takes any string like code or description, and it sets them equal to the empty string. It takes any Boolean, and we don't have any Booleans there, and it sets them to false, etc. So that is what's called typically a parameterless constructor. It's a constructor that you call, and you'll learn how in just a bit, but you only provide an empty set of parentheses. Then we've got a parameterized constructor underneath it. Notice in this case, it expects that when we create a new product object, we're passing in a code, we're passing in a description, and we're passing in a price. And you probably notice if you take a look right there at where my mouse is resting, that code, description, and price are all in lowercase. And up above, when we're listing the properties, code, description, and price all have an uppercase first letter. That is correct. It's not a misprint. All right. Now, when we work with the different things, the properties, the methods, and the constructors for a class, this is some of the terminology that you'll have to start getting used to using. So again, a property is a piece of data. A method is an operation that you can perform on data. A constructor is a special method executed when the object is created or instantiated. A delegate, we talked a little bit about these before. I gave you an example much earlier in the semester. But when you've got a delegate, it's like when you delegate authority. All right. So for instance, let's just say I remember growing up as a little kid, my mom would say, your dad and I are going out, and your older brother is going to be babysitting you. Okay. And then they tell my older brother, while we're gone, you'll do the dishes and you'll do this and you'll do this. And they leave, and my brother right away says, okay, Jeff, you'll do the dishes. So he has delegated authority to me. It's going to be a similar type of operation. An event basically says something has occurred. All right. A field is basically, it's a variable or a property that you declare but you don't declare it inside of a method. You declare it outside of everything. If this doesn't make sense to you right now, it's okay. You're going to see it all in action after the break. A constant is just that, what we've been working with all along. They're a constant. All right. And the other stuff that's in there, let's just put that off right now because it's way too complex. All right, for what we've been doing already. So, couple definitions again. An object is an instance of a class. They call it a self-contained unit with properties, methods, etc. A class is a blueprint. It defines what the object is going to hold. Encapsulation, as it says, lets you control data in operations. If you remember at the beginning of this section, I said in a nutshell that object orientation is about public methods manipulating private data. That private data is data that's been encapsulated. All right. It can only be manipulated in a certain way. Going along with encapsulation is this idea of data hiding. All right. So it says the data of a class is typically encapsulated within a class using data hiding. You want to make sure that anybody who sees it needs to see it. Anybody that manipulates it needs to be able to manipulate it, etc. All right. So they're going to show you the code for this product class. So let's just take a look at it. It's going to look a little different from what we've done so far, and it's a little bigger too when you look at it here. But let's just take it from the top. All right. The first thing to let you know, every single time you create a class, every single time you create a class, classes are just code. There's no GUI. So they're console, basically. Now, you can have classes that are just code inside of a GUI program, or you can have classes that are just code inside of a console app. But we are creating a new class. By default, virtually all classes that you create will be public, which means that other classes are going to be able to use them. All right, so in other words, if later I created an orders class, I might want the products class and the orders class to be able to communicate with one another. So I'd make them both public. Then we have these three fields that you see in here. Now in the past, we have not used the word private when we have declared variables. We have just said things like string code, string description, decimal price. But when you are working inside of classes, all right, you always or virtually always put in here the type of field that you're working with. Since these are private, these three fields, since they're private, these three fields can only be manipulated within this class. And other classes, so if I had an orders class, they would not be able to directly manipulate these variables here unless they use the public methods to do that. All right. So we've got three fields, two strings and a decimal. Then the next thing that you see in there says public product, paren, curly brace. That's what's called an empty constructor. And again, that if I create a new product object like that, that'll take the code and it'll set it to the empty string. It'll take the description and it'll set it to the empty string. Remember, the empty string is double quote, with nothing in between. And it'll take the price and it'll set it to 0. So if I don't know anything, if it's a new product, but it doesn't have a code yet, it doesn't have a description yet, and it doesn't have a price yet, all right, then I can go and set it up that way. Typically, when we set up projects or products in this case, but typically when we set this stuff up, we will know the information. So if we already do know the code for the product, the description for the product, and the price for the product, we do it this second way. All right. And you'll notice that all this stuff in here is prefaced with the word this. All right. And the word this used in there basically just means what I'm currently working with. And it's ugly. And it's like, geez, do we have to get used to using that? The answer is yes. And you will use this in a lot of different programming languages, not just C#. All right. So this is a parameterless constructor right here. This is a fully parameterized constructor right here. So when I create a new product this way, I'll say equal new product paren. But if I create a new product this way, I'll say equals new product paren, and I'll have to pass it in a string representing a code, another string representing a description, and a decimal representing a price. And that's what's going to be going in here. All right. Now, I'm not saying that was easy. I'm not saying that was hard. I don't know whether or not it made sense. But for lack of better words, it probably gets a little harder right now. Because now we're talking about properties. All right. And you're saying, wait a minute, you said these were properties. These are fields. All right. And these fields basically are set in these property designations. And what's going to make this tough is there's probably a good 2 or 3 ways of doing this that all do the same thing, but they look a lot different when you see them in action. So which one are we going to use? The answer is yes. At times we'll use all of them. All right. So here we are setting the code, we are setting the description, and we are setting the price. And it's confusing because these are called getters and setters. All right. When you are born, all right, and you are in the hospital, and a nurse comes up and says, hey, what are you going to name the child? All right. And my parents say, we're going to call him Jeffrey Paul. All right. Then there's a little sticker maybe on the crib that they write Jeffrey Paul Scott. That is a one-time shot. They are setting, in that case, they are setting my name. As I get older and I introduce myself to people, hey, what's your name? We shake hands when we first meet. I am Jeff. Who are you? Etc. That's getting. So when you get something, you're not changing its value. You're just literally asking the question. They're also called accessors. All right. So if you walk into class the first morning and I say to you, hi, what's your name? And you say it's Bob, hi, Bob, etc. I'm getting your name. But if I realize that there's 4 people in my class that are all named Bob, I could call them Bob 1, Bob 2, Bob 3, and Bob 4, but that might be a little confusing. Let's say there's 3 of them. So I call one Bob, one Rob, and one Robert. And I've told them, well, from now on, I'm going to refer to you as Bob. I'm going to refer to you as Robert. And I'm going to refer to you as Rob. That's a set. That's also called a mutator because you are changing the value. And speaking of which, when you see the word value there, you don't have to pass that in. It's just something that's available. That probably won't make any sense until we start working with it. So these are your property setters and getters for the code, for the description, and for the price. And then we've got one extra method in here that's called get display text. And you'll notice that going back to here, this is public, this is public. The only thing private in here are our fields. Both of our constructors are public, meaning that they can be called by other classes. This is public, this is public, this is public, and this is public. So this last one that's in here, it's called get display text. It must return a string, and it must be passed into it a string called sep. And what the heck is sep? All right, it's a separator. Could be a comma, could be a tab, could be something else. All right, and again, I'm not even going to ask, hey, did that all make sense? Because it may have made very little sense. All right, when you create a new object, and remember, so when you are creating a new instance of a class, that's instantiation. Again, good, bad, or indifferent, There are different ways of doing this. So here, just kind of like we did with variables, where we would say like int age1, comma age2, and then later we would set age1 and we'd set age2. You can declare two different types of products on one line like they've done here, product and then product 1, comma product 2. Or when you create the product, you can basically initialize it, and that's what they show in later examples. All right. So if we use this second one here as an example, and we set all this stuff here for product 1. All right, that means product 1 is a new product. Its code will be C#. Its description will be Murach C#. And its price will be $59.50 decimal. If we were to have done the same thing here for this one, for product 2, we'd say product 2 equals new product. Product 2.code equals ASP MVC. Product 2.description equals Murach's ASP.NET MVC. And product 2.price we'd say is equal to 6150. All right. There's even other ways that you can go and declare and create objects. What has happened is over time, the people who write all this stuff keep trying more and more to make it easier for people to understand. Sometimes, rather than making it easier to understand, if you give somebody 6 ways of doing the same thing, sometimes it makes it harder to understand. All right, so they show you some usages of this. And you'll notice that the last one there that says product 5 equals new, paren. You must have C# version 9 or later to use that. All right. And the two that are up above it, one of them says explicitly cast, and the other one says implicitly cast, or explicitly typed and implicitly typed. When something is explicit, it's under the control of the programmer. So if I'm going to create a new product object, I'm letting the system know this is of type product. I am letting it explicitly know. On the other hand, if I want to, I can also come in here and say var. If I use the word var in there, now I am implicitly letting the system know. So when something is explicit, it is under the control of the programmer. When something is implicit, it's under the control of the program itself. All right. And I'll let you read these on your own. They're pretty much what I just mentioned to you. All right. So it is 9 o'clock. We're going to take a break. And when we come back, we're going to jump right back into here. So let's take 10 minutes, please. And at 9:10, we will pick it up talking about basic skills for creating a class. I'll see you in 10 minutes. All right, it is 9:10, so I'm going to continue on. There's an old joke, not a funny joke, but an old joke about how do you eat an elephant? And it's like one bite at a time. All right, the reason I'm bringing that up is when you look at this, I mentioned that there's about 6 portions in this chapter. We went through the first one, an introduction to classes. So right now we're going to go into the basic skills for creating a class. And then we'll go into the product maintenance application. All right. We'll see where we are time-wise there. But that might be it for the period today. We might just pick it up here tomorrow. All right, just because of the fact that this is a lot to get your head around. And I'm really and truly going to ask, I am really and truly going to ask that those of you watching this, all right, read the chapter, especially if you typically don't read the chapter. This is new stuff. In addition, I'm going to send you a URL or two, all right, of where you can get more information on this. All right. And again, when people say, well, I don't have time for that, then don't do it. All right. But it depends on how bad you want to learn this stuff. Okay, so we're going to go through now the basic skills for creating a class. So as it says, we'll talk about how to add a class file to a project, how to code fields, how to code properties, how to code methods, how to code constructors, and how to code static members. Then we'll put all that together in this product maintenance application. Now, just for a second, I don't want to spend much time on this, but just for a second, I am going to change my share and I'm going to go back to Visual Studio. I'm not going to do anything with this other than I just want to show you that if I right mouse click on the name of my project and I choose add, I can either go way down to the bottom and choose class, which is totally fine, or I can go to new item right here. And then what you'll notice is class is the first thing that's here. So if I was going to create in here right now, let's just assume for a second, I was going to create an employee class. All right. So I could come in here then and just type in employee, employee.cs and hit enter. And again, notice what you see here. All right. We get a new class. Now, it becomes internal. Don't worry right now about what internal means. All right. Typically, almost always in here, we're going to immediately change this to public, just so you know. And don't worry about even what that means. But the point is this. What we're going to end up doing in here is just writing code. There is no graphical user interface or GUI in class files. They're just code. All right. So with that out of the way, then let me get back to this. Change my share back to the book again. All right. So let's go into the basic skills for creating a class. All right. I just showed you how to add the class file. They give you, I mean, basically it's what I just showed you. I'm not going to say another word about it. All right. You do get some boilerplate code when you do this. Now, it may not have shown exactly the same thing as what you have here. It doesn't matter. You get a few using statements. You get a namespace rather, which is the name of your solution. And then you get internal class followed by the name that you just gave. And like I said, we will typically change that to public class followed by the name. If you want a little more, you can read this, but I don't think there's really anything that's in here that I didn't already show you. All right. So first, let's talk about how to code fields. Okay. And it says here, a class can contain 2 types of fields, instance variables and static variables. So let's quickly talk about the difference between the two. Every time you create a new object, based off of a class, all right, instance variables will be different. What does that mean? Let's pretend, for instance, that employee class that I just created. Let's say that instead of employee, we call that person. And we just said that every person has a height, a weight, and a gender. All right. Then the height, the weight, and the gender would be instance variables, because for each person object, conceivably, each person could have a different height, weight, gender combination. So instance variables mean that they are different for each object of the class that you create. Well, let's say that every time I created a new person, I also wanted to implement or increment a counter. I had a person counter. All right. So if I made 10 people, I would want a person counter, and I'd want that person counter to be equal to 10. I would have to make that static. Static means that it's shared by everybody. There's one of them. If I made a person counter, but I made it an instance variable, I'd have 10 different person counters, and each would have a value of 1. If I made it static, there would be one counter that would be shared by all 10 people, and it would have a value of 10. Now, maybe that helped, maybe that didn't help, but as always, the more you see this, the hopefully at least, the clearer it's going to become. Virtually always, when you create instance variables, you will make them private. Now, they're going to already in here, they're going to show you exceptions to that just because you can do it. But it's like anything else. All right, I mean, technically, if I'm driving down the road and I'm not in England or in Europe someplace, technically, if I'm driving down the road and there's nobody in the other lane, then technically I can go and drive in the left lane. I shouldn't, if I've got 2 lanes, one going left or one east and one west or whatever. All right. Technically, I can do it. That doesn't mean I should do it, but technically I can do it. I mean, when you create instance variables, virtually 100% of the time, you're going to make them private, meaning that they're only able to be changed within the class itself. All right. If you made a variable public, it can be changed by the class itself and by any other class. All right. And we will talk a little bit more about what public and private, etc., mean in the next chapter. All right. Really, I guess it's chapter 14, they say. So they're going to show some examples. All right. The last example, or the next one that they're going to show in here, is a read-only field. And you go, oh, it's a constant. Read-only fields and constants are not the same thing. When you declare a constant, you have to give it a value right away. If a field is read-only, you can basically give it a value when you need it to have a value. And again, if that doesn't make sense, you're going to see some examples of that in just a moment. All right. So here's some examples. And as you can see at the top here, there's a private instance variable, there's a public instance variable, and there's a read-only instance variable. All right, now when we think about these, quantity, well, let's say that I was creating a bunch of products, because that's what we're going to look at pretty soon. I could have a different quantity of each product. That should make sense. All right, and so it would make sense for, since I would have a different one for each one, that would be an instance variable. Same thing with price. Now, if I say I have a limit of 90 for any product I have, it doesn't matter what it is, then I would not necessarily have to make that an instance variable. That could be either a static variable or something else. Now in here, they also show that if it's read-only, you could make it public. And technically that doesn't hurt. You could make it public. You can't change something that's read-only once it's been set. All right. So it says here, here's a version of the product class that uses public fields. I don't know why somebody would do this. I mean, if you read enough of this stuff and you look at enough videos, etc., some people will tell you that this is the way to write things. I think this is the wrong way to write things. I'm just giving you my own personal take on it for whatever that is or is not worth. So I'm not even going to go over that example right there. Now, as they mention here on the bottom of the page, a variable defined at the class level. What that means is if you define something here that's not defined in any method. So code and description and price were not defined in any of these methods. They were defined in the class, but outside of any method. All right. And as it says, those are called fields, even though technically you can put them any place. So I could have defined them in between these two methods or in between these two or even at the bottom. Historically, they go at the top. That's just the way people do things. These fields, as it says, can be any primitive data type. What does that mean? A string, a decimal, an int, a double, etc. They can also be a .NET class or structure or a user-defined class or structure. What does that mean? That means that these variables that are in here could be arrays, they could be lists, all right? You can have an object that even contains other objects. That's totally legal to do. As it says there, third bullet down, you typically use the private access modifier to prevent other classes from accessing a field. An instance variable, as it says, is a field defined in a class and allocated when the object is created or instantiated. Next, if you initialize an instance variable when you declare it, that initialization takes place before the constructor is called, so it could be changed. You say, I don't get it, you're going to see it in just a moment. If you want something to be read-only, you have to specify the word read-only in there. All right, and public fields again. All right, it says they can be accessed outside of the class, and typically it's not done. All right, so let's talk about properties. All right, so as it says, in just a second, we'll see the syntax for coding a property. Good, bad, or indifferent, there's more than one way of doing this. What makes it confusing is oftentimes programmers in the same program will write the same kind of code in different ways. All right. I don't know why, because they can, because they want to. But sometimes what happens is programmer A does the beginning code and writes code in a certain way. Then later programmer B comes in and she or he is going to maintain that code and maybe add some stuff to it. And they don't write code in exactly the same way. All right, so they're going to show you these getters and setters that I mentioned to you already. So we're going to see them again in just a moment. The key takeaway, though, is a getter cannot change the value of a variable. You can only retrieve it. A setter can change the value of a variable. All right, so getters are called accessors typically, and setters are called mutators. All right, part of the problem with this is some books will basically bundle together getters and setters and call up both of them accessors, which is not technically wrong, which is also not technically right. So there's the syntax as it says there for coding a property. And we can actually even make it simpler rather than that, and you'll see this in just a moment. Where this starts to get confusing. And I mean, I've gone through this with people before, and they're like, well, why'd they do it like this? Why'd they do it like this? Not trying to sound like a smart aleck. I didn't write the language. All right. I can't always explain to somebody why certain decisions were made when someone was coming in there and creating a programming language. You can make guesses, sometimes educated guesses, but a lot of times you have no idea. So what am I talking about? Well, notice when we did this, let me go back for just a second. So we said here, let me go back even further. Where is it? Well, we had that code that we looked at. I don't know where it is. I thought we saw it. There it is. So private string code, and we said that was a field. Then when we actually want to give it a value later, right, then we come in and notice now when we use it as a property, now it's uppercase. When we declared it as a field, it was lowercase. When we use it as a property, it's uppercase. But notice now it's lowercase again. And it's like, why'd they do that? I don't know. All right. And believe it or not, with the example that they showed right here, we're going to see this in just a couple pages up in the book. This example that you see right here can be written even simpler than this. And you're going to see an example in just a minute. So again, a getter allows you to read something. A setter allows you to write something. All right. If you've got a getter and you don't have a setter, that property then is automatically read-only because there's no set. It's just a get. Once in a while, because you don't see it very often, you have a setter without a getter. So it's a write-only property. Like I said, you see that once in a while, just not very often, to be honest with you. All right. Okay, so what's the difference? Well, look at these. With a setter, the name of the property is on the left-hand side of an equal sign. With a getter, the name of the property, let me say that again, I might have said it reversed. With a setter, the name of the property is on the left-hand side of an equal sign. With a getter, the name of the property is on the right-hand side of an equal sign. All right. So as it says, you use a property to get and set data values associated with an object. All right. Typically, each one of these properties has a corresponding private instance variable or field. It's common to use the same name for the property and the related instance, but to begin the property name with an uppercase and the instance starts with a lowercase letter. Again, that's just pretty much standard. And I guess going along with that, because some people still, when you create variables in virtually every programming language that I know, all right, and I don't know how many I know, I don't care. But C#, when you create variables, they should always start with a lowercase letter. Some of you still, at least on occasion, are starting your variables with uppercase letters. All right. Next semester, if you haven't taken that class already, if this is your first class, then next semester, the class you take in spring is AWD1000 Web Development Technologies. And in there, we will talk about JavaScript. Historically, like other programming languages, for years, JavaScript has taken their constants and made them all uppercase. That's changing in JavaScript. And now a constant looks just like a regular variable, all lowercase, but not in this language. All right. So you code a get accessor or getter to retrieve a value. You code a set accessor or a setter to set a value. As it says, a property with both a get and a set is called a read-write property. A property with just a get is called a read-only property. A property with just a set is called a write-only property. Again, those write-onlys are very rarely done. So those were properties. So then what's a method? A method is basically the equivalent of what we've been writing as functions. But a method is written inside of a class. So really, a method is a function that's written inside of a class. All right, it's not a getter, it's not a setter, but it can do things with getters and setters, or it can do things with fields. The example that we're going to see in here may or may not make any sense to you. All right, so there's a method that accepts parameters, and then there's another method that doesn't accept a parameter. And this is going to bring up a really, really, really important point. If you notice, if you look in here, we've got two different methods, and they are both called getDisplayText. GetDisplayText here, right there, and getDisplayText right here. Whoops, sorry, right here. What's the difference? The difference is, in the first case, there's something in the parentheses, and in the second case, there's nothing in the parentheses. When you have something like this, where you create two methods, remember, again, a method is like a function, but it's inside of a class. When you have two methods that have the same name, then those methods must have something different inside of, must have something different inside of the parentheses. What's in the parentheses is also known as the method signature. I want to say that again. All right. What's in there is also known. So what's in here? So the signature in here is one parameter, a string parameter called sep. The signature in here is nothing. When you have two parameters that have the same name, but have two different things inside of the parentheses, but the name's the same of the method, those are called overloaded methods. What goes in the parentheses is called the method signature. So when you overload a method, you can call the method in multiple ways. You can overload something as many times as you want to or need to. We could have overloaded this getDisplayText 10 times if we needed to do so. But in every single occasion, what goes in the parentheses, either the type, all right, or the number of things that are in there must be different. All right. And this is important enough that I'm going to actually break away from this for a second, and I want to show you something. All right. So I'm going to change my share just one time. I don't want to keep doing this today, but this is in a really, really important topic. All right. So if I come in here, hopefully you can see I've got Notepad up on the screen right now. This is going to be real crude and real simple. And I'm going to make this nice and big so you can see it. So 48 should be more than big enough. So if I come through here and I'm going to create myself, that's going to probably be too big, but okay. I'm going to create myself three different methods. So I'm going to put in here, I'll make it public, that's fine. Public, add to, and I'm going to put in here bigger, like this. Come on, there we go. All right, and I'm going to make this a little bit smaller. 36 should be good. Okay, so I'm going to put in here int n1, int n2. Okay, and all I'm going to put in here, this is going to be real simple. Just going to say return n1 plus n2. Okay, and I'm going to copy this twice. All right, so now I've got another public, and this is going to say double. I don't know what that is, but it should say double n1 double n2. And I have to put down what this is returning. So that's returning an int. This will return a double. All right, and I'm going to do it one more time, and this is going to be a string. And I'm going to put in here string n1 string. N2, and I will return N1 plus a blank space plus N2. The reason I'm showing you this is a method that has been overloaded 3 times. So one time it expects 2 integers, one time it expects 2 doubles, and one time it expects 2 strings. All right. So if I were to call this then, let me make this a little bit smaller. All right. So if I were to call this then, I could, for example, I could say this. Int number 1 equals 17. Int number 2 equals 21. Int sum equals add 2, all right, number 1, number 2. And that one is going to call this one because I'm passing in 2 integers. All right. On the other hand, if I had made this a double and I said number 1 equals, let's say 17.8, and I made this a double, and that was equal to 21.6, and I made this a double, all right, then that's going to call this one. And I won't show you the last one because I think you get it. But the signatures in this one and in this one and in this one are all different. And you might say, well, they're all different, but they're all N1 and N2. All the system looks at is the type. Int, double, double, string, string. And they don't have to be the same. I could have another one that brought in an int and a double. All right. And then I could add an int and a double. But I'm trying to show you this idea of doing what's called overloading a method. All right. All right. So with that said, let me jump back into the book. And most programming languages, at least that I know, allow you to overload methods. All right. So that's what they're doing here. We've got one called sep that's expecting a string and one that doesn't expect anything. What's the difference? If you call the first one, that says that we want a tab between every field. If you call the second one, there's just a comma between every field. So this is more on overloading, and it's what I just mentioned to you if you want to take a look at that. All right. I mentioned earlier, and I'm going to say it again right now. A constructor is a special method that gets called when you create a brand new object. And again, an object is an instance of a class. When you create a new object based off a class, it's called instancing the class or instantiation. All right. Now, since a constructor is just a method, you can also overload a constructor. So here's a constructor with no parameters, and here's one with 3 parameters. When you've got a constructor with no parameters, all it does is it takes any values, any fields that have been set at the top of the program. If they're numeric, it sets them to 0. If it's Boolean, it sets them to false. If it's strings, it sets them to the empty string. All right. So here's one with no parameters, one with 3 parameters, and one with 1 parameter. So as always, there's multiple ways of doing this. I don't know if I've given you this analogy before. It may be a good one. It may be a crummy one. But if I come in here and I'm going to go into images.google.com and I'm going to put in here this. All right. If you walked in the first day of class and I showed you this picture right here and I said, okay, we're gonna do something different. I want you to each draw that. All right. Everybody sees something different in there. I don't think that any two would look exactly the same. People could go in and try to basically come in there and make it look exactly like that. But to somebody, maybe maybe here's a better one, maybe. All right. Maybe that banana stuck out. Maybe to somebody else, the red grape stuck out. Maybe to somebody else. All I'm trying to tell you is, since you've got a multiple number of ways of doing most of this stuff, there's no quote right way, unquote. Excuse me. All right. These are those default values that I mentioned to you before. All right, and we talked about static members. Now, I know I mentioned this before, but I'm going to say it again. Years ago, and maybe you've even heard me tell this story before, but I'm going to try to keep it short and sweet. All right. Years ago, I was teaching a Java programming class at another college, and the book that we used, basically what happened was you built a program in the first chapter, and it was real simple. All right. And as soon as the program started, there was a dot on the screen, and there were a button called grow, and there was a button called shrink. All right. And every time you click grow, the button got 10 pixels bigger. And every time you click shrink, the button got 10 pixels smaller. That was all fine. People got it. And then we went in and we started to create other buttons or other, little dots on the screen. And then we talked about, we wanted to have a counter of how many dots we had created. And something like that had to be static. So when you think static, think that there's only one of them and it's being shared. If you remember that one of the things that we've always had in our C# console programs is we've always had one main, and it is said static void main. All right, there's only one of them. And any routines that dealt directly with main had to be static as well. All right. So we've looked at some of that before, but as it says there, a static member is a field, property, or method that can be accessed without creating an instance of the class. Oh, what does that mean? Well, you may or may not remember, or we may or may not have even looked at it, but for instance, when we've used things like int32.tryparse, we've used those. We don't have to make, int32 is a class. Tryparse is a method from that class, but we don't have to create an int32 object. All right. We can just use the int32 because it's static. A better example of that is C#, like most other programming languages, has a lot of static methods like square root or square, etc. And when you create those, if I want the square root of 27, I say math with a big M, math.sqrt, then in parentheses, I put 27. So what it's doing is it's calling the square root method of the math class. All right. But I don't have to instantiate a math class object because it's been declared in the language as being static. All right. It's a little confusing. Hopefully, the more you look at this, the more it'll make sense. All right. And that gets us to our product maintenance application. So let's start to take a look at this. Again, the idea is we're going to look at this today, but just use the code that's in the book, not bring it up and not try to run it. Then tomorrow we'll have it here. You already have this. I mean, you have all the book applications. They were given to you in the same folder where everything else is, but I'm going to bring it up and we're going to take a look at it. There are a few things that are discussed in this chapter that won't make a lot of sense to you right now. And for good, bad, or indifferent, what the people at Murach have decided to do is they're introducing some of this stuff now but they're not going to explain it until a later chapter, just because they don't want to overwhelm you with too much information. All right. So as it says, this is going to be a product maintenance application that maintains a file of products. Let's take a look at it, and then I want to come back to this page in a moment. This is what it's going to look like rather. When you bring it up, it's going to look like this. This is going to be a listing of all the products that we have. So right now, I'm not going to read them to you, but you can see we have 4 different products. Each product has a code, has a price, and has a description. All right. Every time you come in here and you click the Add Products button, it brings up this second form, which is a new product form. All right. And I believe that everything that's in there is required. I will have to check tomorrow. But so if I come back in here and for the code, I write hello. For the description, I write hello. And for the price, I write $500. Then it's going to say hello here, 500 here, and hello there. So the idea behind this is we are going to end up writing classes that are going to help implement this functionality. One of the things that confuses especially newer programmers with this stuff, it's, okay, I get all this stuff. I get everything you're talking about. Couldn't I write this entire application with what I know right now and not use classes at all? The answer is yes, you could. It would be harder, but you could. All right. Notice there's also a delete product. If you, right now, if I were to click delete product and none of these were highlighted, it should come up with a message box that says, hey, you must highlight a product to delete it. So I click on this last one, Murach's Java programming, and I click delete product. I believe that a message box will come up and it'll say, hey, are you sure you want to delete Murach's Java programming? So it's giving me one last chance to back out. If I say, yes, I am, it's gone. It'll be removed from the list and it'll redraw this. This is a list box right here. It's just a listing of all our products. Button, button, button. We come in here, text box, text box, text box, label, 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 button, button. So they explain here everything that's happening. All right, the main form displays a list of products stored in a list box. It says the user can use this form to add or delete a product. Those are your options that are in there. Again, we already looked at this. Or, of course, as always, you can exit the program. All right. If the user clicks the add button, as it says, the new product form is displayed as a dialog where you can add information in there. It's also got a cancel button in case you change your mind. So delete a product, you press in the main form the delete product button. And again, if you've got a product highlighted, it'll say a dialog box will come up to confirm the operation. Finally, they say in here, this figure also shows how the tag properties are set. You already know what tag is. We've already used tag before. All right. So there's the way they're using tag. I tend to put all my tags in lowercase. It really and truly does not matter. All right. It's just a personal preference for me. All right. So everything we just looked at is what's explained in here. Okay. All right. So it says the next figure will summarize the properties, methods, and constructors for the classes that are going to be used in the application. There will be 3 of them. There will be a product class, and guess what? It looks exactly like what we've been working with throughout the whole program or the whole chapter here. There's a product DB class that's not going to be discussed very much because DB is for database, and we haven't talked about databases yet. There will also be a validator class, and guess what? That validator class is going to basically hold the is present, is within range type of stuff that we've used previously. Hopefully, one thing that you'll realize from what I just said, if we can write if we can write a validator class that'll handle any kind of validation. So is something present? Is it within range? Is it decimal? Is it int? Is it double? Is it etc.? If we can write that once and then bring it into any program that needs it on an as needed basis, it's going to save us some time and effort. It'll have already been tested, so it should work as long as I call it in the right way. I should never have to worry about it. All right. And when you do that, you're putting these things into what's called a class library. We will end up creating one of those. And just, I mean, think about the term. All right, because we've talked, you all know what a library is. Why is there a library? So you can share stuff. All right. And it's the same kind of an idea. So the product class is discussed in here. There's the product DB class. They'll show it, but they won't talk about it in a lot of depth and breadth of coverage. All right. And then there'll be the validator class. Notice that the validator class, all the methods that are in there are static. So there's the is present, there's an is decimal, and there'll be some other stuff in there too. We'll talk about it in just a moment. All right. So just so you know, it's 9:51. I'm going to go till about, all right, just like we did before, I'll go to about 10:05, and we'll take another break. All right, then I'll go to 11. No matter where we are then, I'm just going to stop for today. And we'll finish this up tomorrow, and we'll start working on regular examples of this tomorrow. All right, so here's the product class. This is the exact same thing we've been talking about throughout this entire chapter. It has 3 properties. It has 1 method, and has, well, 3 methods total. It has 1 getDisplayText method, and it has 1 overloaded or 2 constructor methods. Then we've got this product DB class. All right. We've got a get products. Why do we need to get products? Because that get products is what's going to fill up this. All right. We also need to save products so that when we put in something like this and we click save, it saves it, and then it calls get products to bring the list box up again with the new product we just added inside of it. All right. Finally, again, we've got this validator class. Everything that's in there should make sense to you as far as those methods. The property is new. And basically, it's a delimiter. So it tells us at the end of an error message, we want to put a \n in there. All right. Again, with this product DB thing, as I mentioned previously, the author says, because you really don't need to know how this works, the code isn't shown here. But in chapter 17, they'll show 2 different versions of it. You don't have to worry why there's 2 versions. We'll talk about it at that time. All right. So in the next several pages here, they're going to show the code. If the code does not totally make sense to you right now, it's to be expected. All right. But we will look at what's in here. All right, we will look at what's in here. And notice the author says figures 1213 to 1215 show the code for the product maintenance, the new product form, and the validator class. They're not going to show the product class code because they already have. All right. As it says here, the code for the product maintenance form, notice what it says. It begins by creating a list of products. So we're going to be using the list. Why a list? Hopefully it makes sense to you by now. We're using a list instead of an array because we want to be able to dynamically add and remove products as the program is running. All right. And again, there's just some explanatory text in here. And we're going to look at the actual text or the actual code ourselves in here. So what do we have? All right. Taking it from the top. This is the stuff that we've had all semester, nothing new there, but right here. Notice the first line that you see at the top. It says private list, bracket product, bracket products equal null. All right. What that means is we are going to have a class called product.cs, and products, all right, lowercase as it's shown right there, will be a listing of these products. Okay. So when we are in main and in our load event, notice the first thing we're doing, we're calling get products. That's going to fill that list box. It's going to go out and grab those products, and then we call fill product list box to actually fill it. All right. And you can see the thing down below it. Now, down below it, we have talked about this, but it's been a while, and I don't remember when we talked about it, but you notice there's a new kind of for loop in there, and it's called a for each. All right. The for each is an easier way to write the code. We could have said something like for, int LCV equals etc., but you typically don't. So what that is saying is, as long as there are products, add them to the list box. After you've added everything that's in there, this is going to call that get display text. That was going to add the code, then the price, then the description, and between each thing, put a tab, just so it reads a little better. All right. This is the code you want to run when you click the add button. This is the code you want to click when you run the delete button. All right, so let's look at the add code first. Well, we're about to add a new product. So the first thing that we're doing in there is we're adding a new product. All right. And then we're saying that product equals get new product. What does that mean? All right. Well, it's not explained really in here, but it's grabbing everything that we had in that form. And as long as there's something in it, we're going to add it to our list of products. And then we will call fill product list box to update the list box showing the new product. When we delete, all right, you should by now know that selected index, what that means. If it was equal to -1, right here, this line, if it was equal to, I know we're checking not equal to, but if it was equal to -1, nothing's selected. So as long as it's not equal to -1, a product was selected. So this basically grabs it and it says, are you sure you want to delete this? And it gives you a message box. If you say yes, it doesn't come back and say, are you really, really sure? It just deletes it. Right? So you're given one chance to back out. So here's the code for the new product form. So what does that mean? This is for products.cs. So what does that mean? That means we've got here, look, you've got private product equal null, public product get new product. Again, what does that mean? That means that when you start, there's no product. It's null. All right. Then this thing right here that says this.show dialog return product. Well, what does that mean? That means that when you want to call get new product, you basically will have to show a form that's going to show that stuff that allows you to put that in there. And inside of there's going to be a save button. Before you go and save it, you have to check to make sure the stuff that's in there is valid. So you're calling is valid data. What is that doing? All right. It's making sure that there's something in each one of those. First, that's the is present that you see down here. So if we leave any of these fields empty, we're going to get an error message. Let's assume for a second we leave all of them empty. All right. It's going to basically say entry error 3 times probably. I don't know if it will or not. But all this is doing to validate is it's saying are all of these present? That's all it's saying right there. Now, is that everything? No, but think about it. We have to also make sure that for the quantity or whatever that other field was, the price has to be not just present. All right. Is it a decimal? Okay. Now, if that fails, it doesn't matter if there's something there or not there. Because if it fails, if the is decimal check fails, it means we put something non-numeric in there. So either it was empty or we put something else that was non-numeric. So we don't have to check for is present. We only have to check for is decimal. All right. If there weren't any error messages, so if error message is not, well, this is check if there are any error messages. So if it's not equal to the empty string, we want to say, we're not successful. Success equal false. This is what I called ret val all the time. And what I was doing, they're calling it success. So you set it to false, but either way you return. Cancel, you just close it. Basically, you were going to bring up something new and you changed your mind. All right. Then for the validator class right here, this should look pretty similar to you. What's new is this line terminator. They'll explain this, but they don't really spend a lot of time talking about it. This you already know, but it's public now and it's static, meaning that all instances will share the is present, the is decimal, etc. All right. Now it says there are two other ones, the is in 32 and the is within range. They're not shown here because they're not using them in this application. But this stuff that's in here, it's all the same stuff we've been using. All right. We were passing in text boxes. All right. Now we've got string value, string name, which basically is going to be our tag name. All right. And a value that was in the text box. All right. It's a little bit early, but I'm going to stop right here and we're going to pick it up. So let's see exactly where we are. So we have now gone through an introduction to classes, the basic skills for creating a class, and the product maintenance application. All right. So what's left, and maybe we can finish this by the end of the period, we'll see. We've got about 20 pages to go. We're going to go through this more skills for creating a class, and you're going to see different ways of doing this. Then we'll talk about some of the built-in functionality that is inside of Visual Studio. And if there's time, otherwise we'll start it there tomorrow. We'll finish up by talking about structures and records. So it is 10:03. Let's come back, please, at 10:13. We'll pick it up right here.
what's going on, guys. So in this video, I want
All right, as we start up, I backed up a little bit because I wanted you to see this. This is this thing here called line end, and this is the getter and the setter for it. If when you do the getter and the setter, you just want to return or set a value, if you just want to do that, there's a shortcut for it. And you can do it like this. So you would have said public string line in, then just get set. All right, like this. Okay, that's just a shortcut. Now, why would you want to use that? The answer is you'd want to use it whenever you can, but when you're doing the getter or when you're doing the setter or both, if you're doing any kind of logic in there when you want to check, for example, let's say that you were going to set an age and you wanted to make sure that it wasn't negative and it wasn't greater than maybe 125 or something like that, then you wouldn't want to use one of these. You'd want to actually put the code in there. But what they're showing here is what are referred to as auto-implemented properties. All right, it just makes it a little bit faster. It's a little less code that you have to write. Okay, and there's even some other ones. I've never used this get init, so you can read that one yourselves. But under the description here, and I'm on the bottom of page 403, if the get accessor simply returns its instance variable and the set simply assigns, you can make these auto implemented properties. All right, it's just a little less typing. You don't have to do that. You can still do it the way that they showed it earlier. Now, it says how to code expression body properties and accessors. So again, it says in the last figure, you basically saw if you weren't going to do anything. In some cases, it says you'll need to code a property that returns the value of an expression rather than a private instance variable. So maybe you want to go out and you want to check, let's just say a database, even if you don't know what that means. But let's say you wanted to check something to see if something was there or how many met a certain criteria or whatever. So what they're saying is rather than hard coding a value, what you can do is you can also go in and do some processing. Now, if you do some processing like is shown right here, of course, you wouldn't use those auto implemented ones when you just say get or get set. All right. And there's another way that you can write this as well. So rather than writing it like this, private string code, get, return code, set, code equal value, you can also write it like this. And again, I've mentioned this to you previously that be it good, bad, or indifferent, you oftentimes see in the same program, sometimes even in the same class, this stuff being done in a multiple number of ways. All right, which as you're learning, of course, can make it confusing. I would say that as you are going through and learning this stuff right now, my suggestion is look at all of the stuff that's in here. And if there's something that is in here to be done that seems, oh, that makes more sense, I would use that way, even if it means writing a little bit more code. So as it says, if a property is read-only and simply returns the value of an expression, you can code it as an expression body property, which is fairly new. And to do that, you can use the lambda operator. The lambda operator is an equal sign followed by a greater than sign. And it's funny because in many programming languages, that's called a lambda. All right. The reason I'm telling you that that's funny is, for example, when you work in advanced JavaScript, that's typically called the fat arrow operator. So it just depends on what you're working with. How to code expression body methods and constructors. And they mentioned there in chapter 6, some of this syntax we went over. but we didn't really ever use it before. Well, the time has come, so to speak. So there's different ways that you can use this. Again, be this good, bad, or indifferent, there's oftentimes 3 to 6 or more ways of writing the same thing. And I know I keep sounding like a broken record here, but the one you should select is the one that makes the most sense to you. So if you're shown a couple ways of doing things and you're like, I could take or leave either one, then you just pick one or you use both. Again, the problem with doing things and using a multiple different number of different ways of doing them as you're learning is it can lead to code that could confuse you. All right. So I would just recommend going with one, but you don't have to do that either. So as they say here on the bottom of page 407, if a method returns an expression or just executes one statement, you can code it as one of these expression bodied methods, which again use this lambda operator. If a constructor contains a single statement, you can do the same thing. Again, the stuff that's in here they're fairly new inventions to the language. All right. Next here, starting on page 408, is they talk about pattern matching. All right. It says in some cases, you'll need to code methods that test if an object is of a particular type. All right. It says to do that with C# 6.0 and earlier, you had to use the get type method and the type of, but there's another way that you can do it today. All right. Much of the stuff that they talk about in here is fairly complex. So again, if it's not totally making sense, that's why I mentioned, like I said, I'm going to go right now. I'm going to go till around 11 o'clock or so. And if we don't finish, that's fine. What I'm going to do tomorrow, what I think I'm going to do at least, is we're going to go over, if we don't finish up the entire chapter today, we'll finish it up first thing tomorrow. Then we're going to go over this product maintenance application that's in there. And then I might even rewrite it to do something else that's similar, just because I'd rather inundate you and give you tons of stuff and show you the same kind of thing over and over and over again so that it makes some sense to you. All right. And then we're going to go in and start looking at what's going to be assigned for homework and what's going to be assigned for labs for this. That stuff will not be due this Sunday. It's just too much to expect from people. So rather than having it due, this Sunday is the 16th, I think. Yep, it'll be due the 23rd. So you will have work that'll be due the 23rd and probably work that'll be due the 30th. That's what I'm looking at right now. All right. It says to simplify the way you test for object types, starting in C# 7.0, they introduced something called pattern matching, which uses an if statement and an is operator. And again, you might be thinking, that's fine and dandy. Do I have to worry about this stuff? Well, we'll take a look when we got your home, when you look at the homework and you'll see whether or not you have to use it. What they're saying is you used to have to do it like this, like it's shown right there. Okay, now you can do it like this. Again, it's a little less code. And what's happening is they're taking a little bit of the honest, a little bit of what had to be done by the developer, and they're putting it right into the software. I'm not saying that's a good thing or a bad thing. It's a thing. All right. And then there's a little explanation of that down here. I think that's enough to go through that for right now. And then they show how you can use these property patterns. Again, like I said, I don't want to give you too much just because I can see where that would just be pretty doggone confusing. You may or may not remember when we looked at this stuff. This was like back in chapter 6 when we looked at that operator. All right, and I don't even remember right now what the name of that operator is. All right. Okay. And it's, again, I can't say this too many times. you don't go through this chapter today. And let's say that, okay, we go through the chapter today. You're cool with everything. You're like, I sort of understand what he's talking about. I go through a couple examples tomorrow. Yeah, those make sense. I go through a couple more examples on Thursday. Yeah, those make sense. Yeah, I get all this. No, you don't. I don't. I'm constantly learning more and more about this every time I do this stuff. So the idea is, yeah, again, we will do probably one or two of the homework problems, one or two of the lab problems. I don't know. I haven't looked at them yet. You will still be responsible for those, but you will have to do the other ones as well. And they're going to test you. And what I mean is, most of that stuff is not real simplistic to do. All right. So it says, in addition to the skills you've learned for creating classes, there is a feature in Visual Studio called live code analysis to generate stubs for a class and its members. What are stubs? It's a little bit of starter code that you can use to help you get started. All right. So when you do this, sometimes what's going to happen is you create something like this. Product equal new product. Okay, you'll put that into your regular program and it'll come back and say, you don't have anything called product. That's why you're getting the red underline. But over here, it says, hey, would you like me to build this product.cs file for you and put in some beginning code? And if you choose that, it'll do that for you. And that's what they're talking about. That's this live code analysis. Now, some people are like, I don't even want that. I just want to build my product thing first, then add this code. Then you won't get an error like that. So, as mentioned right here, the live code analysis feature lets you generate code stubs. And again, a stub is it's the beginning of what you're going to create for a class. To generate it, as it says, click in the line that contains that, a light bulb should appear, and then select the appropriate generate command. When you enter a class or member that hasn't been defined, it says you should use suggestion mode for a statement. All right. And to do that, as it says, you can click Edit, IntelliSense, Toggle, Completion Mode, or there's a Control-Alt space bar. That's way too much to be thrown at you. I get all that. All right. The next section that's in here for the next 4 or 5 pages talks about, again, some more of the built-in features in Visual Studio, as it says there, to help you browse, display, and edit classes. It says the easiest way to browse classes. Now it says in VS 2019, we're using 2022. To my knowledge, none of this has changed. But it says the easiest way is to use the Solution Explorer. Well, you know what that is. You know that this over here is your Solution Explorer. All right. So you can come in there and you can drill down the stuff that's in there. Maybe we'll look at this tomorrow and it'll show you, you can drill down in a class and it'll show you the members of the class, the stuff that makes up the class. In fact, I think that's what they say in here. So you can use the Solution Explorer to browse the classes, to display them. All right, it says expand the file for the class, then expand the class. Okay, to display the C# code, it says double click the member in the code in the Solution Explorer, and it'll bring up the appropriate code snippet. All right, how to use the peak definition and go to definition features. Peak, typically in a programming language, means it's a look ahead type of feature. And when you are looking ahead like that, it is looking to see, for instance, if I'm reading, let's just say I'm reading a file of information and it's got a list of employee names. And I can do peek and it'll show me the next employee name. Once I reach the end, when I do a peek again, it's going to be end of file. So again, it's a look ahead feature to make sure you don't do something you'd regret, for lack of better words. All right, it says there, as you're developing the code for an app, that uses custom classes, you may need to view the code for the class to see how it works. It says, although you could do that by displaying the code in another code window, Visual Studio 2015, so years ago, introduced a better way of doing this. It says to do this, you can use the peak definition window. And they're showing that in here. All right. So you click on something here and it shows you the corresponding code in there. So as it says, you can use this to display and edit code for a member in another class from the class that refers to it. So this doesn't even have to be in the same class. This can be referring to something in a different class. To display it as it says, right mouse click on a member in the class and choose peek. Again, it doesn't help to show you pictures and read to you. I don't want to do that. If you decide you want to use this, the way that you're going to learn is to literally just take a look at it. That's the best thing I can tell you. All right, maybe this is going a little faster than I planned, but we've got about 6 pages left, so let's finish this up on structures and records. All right, you'll notice the first question or the first sentence in there is kind of golden. A structure is similar to a class, but it defines a value type rather than a reference type. What the heck does that mean? A class is a reference type. So if I declare a new class variable, that variable does not hold the class. That variable holds the address in memory where that class lives. That's what a reference variable is. On the other hand, a structure, which is typically used for stuff that's smaller, is a value type. So it actually holds copies of whatever data you have in there. All right. A record rather is like a structure, but it's a reference type like a class. So are you going to need to know this? The answer is the only reason that you should need to know structures and records in this is for the written test. All right, I believe you're asked questions on there. I could be wrong, but I don't think I am. So, says the next figure shows you how to create a structure. All right, well, when you look at this, it looks a heck of a lot like a class. What's the difference? Public struct versus public class. All right, you can also make structures, an entire structure that's read-only. So as it says here, and I'm just going over this for completeness, again, you should only need this for the written test. You shouldn't need it for homework. You shouldn't need it for labs. You shouldn't need it for the test that we'll eventually do on chapter 12. So a structure is similar to a class, but again, it's a value type and not a reference type. It can contain the same members as a class. In other words, fields, properties, methods, constructors, etc. All right. Unlike a class, a structure cannot include an empty constructor. A structure can contain constructors that accept parameters. But if it does, as it says there, it must initialize all the instance variables inside of that. To initialize an instance variable, the constructor must refer directly to that variable. It can't refer to the property. Like before we did a this.code, here if we had something that was called products, the structure would be products.code. If the value can't be changed, it should be declared read-only. And finally, to initialize an instance variable, a constructor must refer to that variable unless the property is an auto-implemented property. The next figure on page 421, as it mentions, shows you how to use the structure. All right. Now, I believe that structures are a fairly recent advent in this language. Okay. And why? Who cares? Well, other languages support structures, which is probably why they made them available in C#. Finally, how to create and use a record. So on the next page, they show you the syntax for a record. Notice as it says, the syntax is similar to creating a class or a structure, but rather than saying public class or public structure, as you can see, it says public record. A record can have all the same types, like classes, but unlike structures, records support inheritance. That's chapter 14, so don't worry about it right now. So they go back and they rewrite this product, but they write it as a product record as opposed to a product class. Is there any advantage? Is there any advantage to using a record versus using a class? I would say that you have more functionality by making them classes, and there's more built-in methods. But there are some things that you can do with records that it's very hard, if not impossible, to do with classes. Okay. All right. And that's it. All right. It says at this point, you may be wondering, why do we go through this extra effort of taking our application and breaking it up into classes? And as it says there, the answer is twofold. First, dividing it makes it easier to use the code in more than one application. All right. Second, classes help you separate the business logic and the database processing from one another. All right. It says, now that you've had this introduction to the use of classes, you can continue in two different ways. If you already feel comfortable, you can read the next 4 chapters. All right. On the other hand, if you're new to programming, you may want to skip section 4 or 5 to section 4 or 5 to see how the business classes are used. We're just going to keep doing it in order. So one last time, be done in 2 or 3 minutes. Tomorrow, we are going to go through this example that's right here. All right, in a lot of depth and breadth of coverage. Okay, I'll have the code. I will resend you this file tomorrow, even though you should have it, just so that if you want to bring it up while I'm going through this, you can do so. Then I'm going to go back and I'm going to rewrite this. I think, at least, if I have time to do this tonight. And instead of a product maintenance form, it'll be a person maintenance form. And every person will have in here, we'll just have first name, last name, and age. All right, so this will be very simplistic and it'll look very much like this. Why am I doing that? Because it'll also allow us to go in and use the is within range, because a person must be 0 through, let's say, 125 type of an idea. So we'll look at 2 similar examples. If there's time left, and there should be, then we will jump into the homework that's going to be due at the end of the chapter and look at that. All right, and then if there's still time left, and there probably will be, we'll go look at the labs for chapter 12. All right, and we'll, like I said, we'll see where we are right there. Okay, and then Thursday I will do a little bit of work with this stuff with you. Okay, Friday is going to be our typical lab day, and probably, at least right now, probably next Monday, I will make a lab day also. Then you could look at Tuesday as we'd have a pretest, and your test on chapter 12 then would be a week from tomorrow on the 19th. That's what I'm looking at doing right now. All right. So, and unless you have any questions, I guess that's it. And I will talk to you tomorrow. Have a good day.
Thanks, you too.